Bienvenidos, Ushamdid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the Spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and in this tutorial video, we're going to be taking a supplemental look at virtual routing and forwarding, and specifically VRF-Lite. Now, this is part 3 in this 5-part series, and we've already taken a look at how to perform VRF-Lite, where we are using dedicated individual interfaces between the routers, and each interface can only belong to a single VRF. And then in part 2 of this video series, we looked at using 802.1q trunking and tagging using sub-interfaces off of a single physical interface between two routers, and then we put those sub-interfaces into the VRF and associated those with the same VRF, and we've seen how we need this end-to-end connectivity between the VRFs in order for our VRF-Lite configuration to function properly. In part 3, we're going to be talking about the similarities and differences between doing back-to-back frame relay. And I'm going to talk about the semantics involved with why you simply just can't go into a serial interface and create a sub-interface like we can over here on Ethernet. Now, we need frame relay to do kind of what we're doing over here. It's going to achieve the same goal. However, we do it a little bit differently. So let's first get into router 8, where we're going to test our connectivity to make sure that everything came back up, and actually that's router 9. So let's get into router 8 here, and let's go ahead and say ping VRF red 10.1.1.1. Remember, this is the simulated network segment behind router 1, and we have connectivity there. Let's ping VRF blue and make sure we have connectivity there. And then finally, let's ping VRF green and the IP 10.3.3.1. Again, all three of these networks are over behind router 1. And so from a realistic perspective, you could have router on a stick here where there's a connection that comes off of one of the interfaces, maybe an expansion card, and it comes over here and it connects into a switch. And then it's off of that, you've got the red network and the blue network and the green network. And you're simply doing router on a stick here using the exact same 802.1q tagging. Because remember, 802.1q is all about Ethernet, right? It's all about Ethernet. And that's the significant difference that we have here between creating a sub-interface on an Ethernet segment where the encapsulation is done a certain way and doing it on a serial interface. And so let's take a look real quickly here at what an 802.1q frame looks like. And you can see right here, when we're doing 802.1q, you've got your destination MAC, you've got your source MAC, and then you have this tag. And that is when we say encap.1q and we put the number 10, 20, 30 for each of the VRFs that we're working with, that tag is what is differentiating the traffic that is coming in. And then traffic can be sent to the correct sub-interface. Just like with a VLAN, it allows us to segment and to segregate, but yet still identify going over a trunk link between two switches, the traffic that's going back and forth. It's all about that 802.1q tag value. However, remember, this is an Ethernet frame, right? On a serial interface, what is our encapsulation default at layer 2? Well, the encapsulation, that's the default encapsulation at layer 2, is HDLC. How could I see that? What if I say show interface serial 000? And you can see right here, encapsulation HDLC. What if I say show it's not gigabit, it's going to be fast Ethernet, just 00. What is the encapsulation? Encapsulation ARPA, meaning it's Ethernet, right? And so these Ethernet interfaces are very different from the serial interfaces that you're going to be working with for this back-to-back frame relay configuration. Again, the encapsulation, and there's usually, you'll see a little C right here before the HDLC for Cisco HDLC, because HDLC is an open standard. Cisco took it, added their secret sauce, and it's C HDLC. Now, with C HDLC, it is probably the most basic encapsulation that you could do on a serial interface. Again, it doesn't have to be rocket science because we're talking about interfaces that only have one device on either end of the interface. And so with HDLC encapsulation, it just provides us that encapsulation that's needed to go between the two devices. Now, when we want to break an interface into sub-interfaces, so if I was to get into global config and go into interface serial 000, and if we say do show IP interface brief right now, you'll see we have a few serial interfaces, but this serial interface specifically goes between router 8 and router 9. This is going to be the interface which we will carve up or create logical sub-interfaces on. However, watch this. If I was to say interface serial 000.10 for VRF red, you can see that it drops me into the sub-interface configuration. Now, let's look and see, is there an encap.1q? Well, there's an encapsulation command. So if I say encapsulation and we do a question mark, you can see that it comes up and it says the command is unrecognized. Whoops, sorry, we didn't want that. We wanted that encapsulation question mark, and you can see that it comes up and says it's an unrecognized command. Now, in an Ethernet interface, under that individual interface, and we can come to router 2 and take a look at that. If I get into privilege exec and say show run interface gigabit Ethernet 03.10 or 03.20. So here's where we would immediately come into the interface, and with an Ethernet interface, we would say interface gigabit Ethernet 03.10. So we'd go into the sub-interface. We would declare the encapsulation, right? How are we going to differentiate this sub-interface's traffic from the other sub-interfaces on this router? Remember, here's that .1q, the 802.1q frame, and we throw a tag in there. And think of the tag is like a little identifier that allows this sub-interface to service the traffic between these routers, between router 2 and router 8, that goes back and forth on the individual wire between the physical port, gigabit Ethernet 03, and then fast Ethernet 01 on the other side. It's this .1q encapsulation that allows that Ethernet link to differentiate between the traffic, whether it's going to be .1q with the tag 10 or with the tag 20 or with the tag 30. And then we have our VRF forwarding. Again, from the control plane, or I should say the forwarding plane with the rib and the fib, right? And we're separating it out using the VRF-Lite configuration that we have here. And then we put our interface on there. And so again, this is critical with Ethernet. Because remember, I can't even put the IP address on this sub-interface until I declare the encapsulation. Well, when we're working with serial links, it's very, very similar, but it's a little bit different. In fact, we'll start here with router 8, and we'll do the configuration on router 8. So you'll notice I go into the serial subinterface here, and the encapsulation command, I can't say .1. You notice it doesn't allow me to say .1Q and then to put a number because it's not Ethernet. Remember that. The encapsulation is not Ethernet, or I should say the layer 2 is not Ethernet. Here it's HDLC. However, there's a legacy technology, which you might find out there somewhere still, that will allow us to carve up this interface and to simulate that encap.1q command, however, using frame relay. But the way that we do it is a little bit different. So if I say do show IP interface brief, you can see that the sub interface was created. However, there's nothing that we can do with that sub interface right now with the encapsulation command. I can't change the encapsulation on the sub interface. However, this is how frame relay does it. So let me exit out one level there. Let's get an interface serial 000. I'm going to say no shut, and we're going to bring that interface up. And so we'll probably see some messages. Remember, on the opposite side, router 9, everything is down right now. And so here's how we would deal with that, is that we don't put the encap statement. The encapsulation statement doesn't go on the sub interface when we're doing frame relay. In order to allow me to do what I need to do, I say encapsulation, and you can see we've got some different types of encapsulation here. No Ethernet, right? iOS knows this is a serial interface. I can't do 802.1q on the serial interface. So there's HDLC, right? And that, again, it's CHDLC for Cisco's HDLC. This is the default. We saw that. And then you've got PPP, which is also extremely popular, the point-to-point protocol. And for CCNA studies, you'll see this everywhere about creating or about using PPP encapsulation, and then you can use PAP and CHAP. And so what we want, though, is we want frame relay, because this is going to be back-to-back frame relay. So all I have to say is encap frame relay. Now, by default, it's just simply going to use the Cisco frame relay, right? Or I could change the encap setup to IETF or MFR. But again, just leave it at the default, encap frame relay. Now, there's one other command that we're going to need, because we're doing back-to-back frame relay. And what that means is, and let me actually jump back to the diagram, what that means is there's no frame relay switch between these two routers. Again, it's back-to-back, router to router, nothing in between. And typically you'll have a frame relay switch of some kind. And again, it could be a router that's serving that purpose in sort of the provider network. However, here we're literally connecting these two routers back to back. And therefore, what I don't need is I don't need the local management interface maintenance protocol, right? And think of LMIs as OSPF hellos from the perspective that it's like a keepalive. It's a maintenance protocol. It's going to make sure that the connectivity is there between the devices, like the hello packets do between OSPF neighbors. But again, that's if we had frame relay switches to which we were connected going through some kind of provider network. That is not the case here. This is back to back. So I'm going to say no keepalives, right? And you can see I'm just going to say no keepalive, and that turns off the LMI messages, those local management interface messages. And again, LMI was one of those popular CCNA and CCNP and CCIE written exam questions back in the day, because you could have Cisco, you could have ANSI, and then the Q933, I believe is what it was. And so you would get all kinds of questions around, you know, for the LMI interface, is it going to be Cisco? Is it going to be Q933? Is it going to be ANSI? What's it going to be? And so we say no keepalive because we do not have any of the frame relay switches between our devices. So now I can go into my sub interface, interface serial 000.10, and what we could say is we could do the frame relay, and it's going to be interface DLCI, the Data Link Connection Identifier on an interface or a sub interface. And in a frame relay world, here is what the DLCI provides. And you can see right here, this is the frame format for a frame relay frame. And it says it modifies the HDLC header from a 1-byte address to a 2-byte address field as seen above. Now, what is one of the things that changes? You can see that we've got 10 bits dedicated here. You've got 6 up here and then 4 down here, the high order bits and low order bits. But this DLCI value, right? This represents the same DLCI value. And you can think of this when I say encap.1q 10, that 802.1q tag has a value of 10. When I say frame relay interface DLCI 10, this value is 10. And it's doing something very similar. It's allowing me on a sub-interface basis, just like with the encap.1q command on an Ethernet interface, on a serial interface using frame relay, I'm able to think of it as tag the traffic with a DLCI value. And then that's the value across which, again, if we look at this, the diagram really sort of tells the picture. I couldn't put a green and a blue here, but all 3 sub-interfaces are going to be sitting on that individual link. And so how, if it's going into a single physical link, do I know how to parse out, well, which traffic is for which subinterface? We use the Data Link Connection Identifier with frame relay, the DLCI value. Just like on Ethernet, we use the 802.1q tag. Now remember, you might be asking, well, why can't I just say encap.1q over here? This is serial, HDLC, layer 2, right? This is Ethernet. Very, very different. The Ethernet frame format is not the serial or the frame relay frame format, right? It's not the same. Or the HDLC frame format. They're not the same. Remember, on Ethernet interfaces, if I was to say, do show adjacency, and we might have to, hopefully this is going to give me what I expect, and I want detail. Remember on the, and right now we only see those interfaces. As soon as the serial interface comes up, remember, you no longer see ARP. And there is no MAC address. That is an Ethernet convention, right? Remember, the MAC address is an Ethernet convention. If we look at the Ethernet frame, I'm sorry, the Ethernet frame here, you can see destination MAC, source MAC, because it's a multi-access type convention. So I need to be able to identify the source and destination MAC for all the Ethernet frames, because there could be multiple participants on the Ethernet segment. And that is how those are identified. If we go back to frame relay, where is the source and destination MAC here in the frame relay frame? It's not there, because frame relay runs on serial interfaces, typically point to point, but we can use the DLCI value to allow us to do sub interfaces. And so hopefully you see the similarities. And again, I'm going to come back to this when we get our configuration sorted out. So do show run interface serial 000.10. Where did we leave off? So you can see that we don't have any configuration on here. So what I need to say is frame relay, interface DLCI. In other words, if this was an Ethernet interface, think of this command as me saying encap.1q, oops, sorry, I don't want 10. Have to go above 16. And so here's what we'll do. We'll do for 10, we'll just do 100, right? Or I'll do 110. We'll do that. And so think of that as me saying encap.1q 10. on an Ethernet interface. I changed the encapsulation, right? encap.1q10 on a subinterface on Ethernet. I come onto the serial interface. On the parent interface, you say encap frame relay, and then you say no keepalive. Then you go to the subinterface, and it's kind of like you're entering in the encap.1q with the value command here. And then the only thing left for me to do now on router 8 is to say VRF forwarding, oops, sorry, going to pop out of, I'm in the DLCI subconfig there. On the interface subconfig, VRF forwarding red. Now I can put my IP address on here. So it's going to be IP address 169.254, again, using those link local IPv4 addresses between router 8 and router 9. And this is router 8, and we'll make it a 24. Not a problem. I've just completed the setup for the subinterface serial 000.10. And again, you can see here, the subinterface number that I'm using does not have to match the DLCI, and I'll say tag, right? Just think of it as a tag, the DLCI tag. Just like on Ethernet, the subinterface number gig 03.10 doesn't have to match the encap 802.1q tag value. Now, again, you'd be crazy not to do it. Here, we're going to go with a one-off because the first 16 are reserved, 0 through 15 are reserved here. And so we're just going to go with a one-off and do 110. So let's do the next interface now. So again, interface serial 000.20. And sorry about that. And we got to, oh, that's right. We need to say point to point. So hold on one second here. Let me do show run interface serial 000.10. And we need to, yeah, okay. And it put it in there by default for me on the first one. However, on this one, right, I'm going to have to put that in there. So that serial 000.20, and I need to say that it's point to point. And then we can say frame relay, interface DLCI, and we'll say 120, right? encap.1q 120. And this is, again, locally significant on this router until we configure the other side. Remember, where those DLCI values need to match between the two. And then we're going to say VRF forwarding. Oh, I keep forgetting I'm in the DLCI subconfig. VRF forwarding. In fact, maybe I should be doing the VRF first. So we'll say VRF forwarding blue, IP address 169.254.89.8, and we can use the same IP address because they're in VRFs. Remember, this VRF-Lite configuration, we're looking at just simply different ways to apply it with dedicated physical Ethernet links, with a sub-interface Ethernet link, and now with sub-interfaces on a serial link using frame relay encapsulation. So we've got our IP address on there. So now let's go into interface serial 000.30 point to point. Whoops. And it's because I'm in the, yeah, what's the POIT? I didn't have the context sensitive help there, and I hit tab, and you might have heard it go click, click. So point to point. So let's do this right out of the gate. Let's say VRF forwarding green, and then we'll say, not encap, sorry. I was going to type encap.1q. Frame relay, interface DLCI, 130. And then I'll put my IP address on here. So we'll say 169.254.89.8. We'll make it a /24. And there we go, right? So actually, do show IP interface. Let's say do show run interface serial 000.30. And we'll make sure everything looks good there. And we'll say 20. And that is point to point. So we're just really what we're doing is we're creating using a single physical serial point to point link. We're using frame relay and the DLCI tag value to carve up the single physical serial interface into multiple logical point-to-point interfaces. And we're using our VRF-Lite configuration to ensure that each of these serial point-to-point subinterfaces is in one of our VRFs, green, blue, and red respectively. So now that's set up, let's take a look at our OSPF configuration. Do show run section router OSPF. So here's the OSPF config. The passive interface is going to need to change, right? So let's go ahead and say router OSPF1 VRF red. And we'll say no passive interface serial 000.10, right? And then what are we going to do? Let's add our network statement in right now. That way we don't need to come circle back over here. 254.89.8 area 0. Let's go into router OSPF1 VRF blue and VRF OSPF2, sorry, OSPF2 VRF blue, and we'll say no passive interface serial 000.20. And then let's put in that network statement with hitting the up arrows, right? Because I've already used that network statement. And then we're going to say router OSPF3 VRF green, and we're going to say no passive interface serial 000.30, and then we'll just hit the up arrow a few times and add the network statement. So now we've got this network statement added over here on router 8. We've got all of the serial sub interfaces, point-to-point sub interfaces done. So now let's come over here to router 9. And this is where we're going to make the magic happen here on router 9. So we'll go from user exec to privilege exec. We'll get into global config. And let's say do show IP interface brief. So we take a look at the configuration here. You can see that the serial 00 interface, we don't have any configuration on this router, in fact, at all. And so other than the host name. And so let's go ahead and let's knock this out. So I'm going to go into interface serial 000. Again, the extra zeros are free, right, in case you type extra zeros in here. We're going to say no shut. We're going to bring the interface up. Now, encap frame relay, right? Think of it as me saying encap.1q and just sort of enabling 802.1q encapsulation on this interface. Again, on Ethernet interfaces, I do it under the sub interface. On the serial interface, I enable the encapsulation for frame relay, and then that's going to allow me to go into the sub interfaces and configure those. We say no keepalive to turn the local management interface, that maintenance protocol that we don't need because there are no frame relay switches between router 8 and router 9. So now I'm going to say interface serial 000.10, right? So we go point to point. So point to point. There we go. All right. Now, first thing we're going to do is I'm going to say, oh, actually, you know what? We're on router 9. We have no VRFs here on router 9. So let's sort that out first. So VRF definition, red. And again, is there anything else I need to do? Yes, address family, IPv4. And then I'm going to say VRF definition, blue. And then we'll say address family, IPv4, VRF definition, and I don't need any of the route distinguisher values configured. I don't need any route target values configured. And address family IPv4. And now let's get back into our serial 000.10 interface where I can say VRF forwarding for red. And then it's here where we're going to say frame relay interface delci of 110. Again, think of that as like the encap.1q tag, except we're doing it with frame relay on a serial interface. And now I'm going to go ahead and put my IP address on here, 169.254.89.9. And there we go. So can I ping, right? Let's check right now. Before we do all the interfaces, let's check and see, can I ping in VRF red over to the 169.254.89.8? Because again, that's the sub-serial point-to-point sub-interface over on router 8, and take a look at that. And all we're really doing is the same thing we did on the Ethernet side, except we need to tell the main interface, serial 000, that, hey, get ready, your encapsulation is going to be frame relay, and then I come into the sub interface and issue the frame relay interface DLCI command and throw a tag on there, 110. And that is how the traffic is distinguished between each of the sub interfaces, these point-to-point sub interfaces. And so now we'll wash, rinse, repeat for the rest of the sub interfaces. So interface serial 000.120. Point to point. I always forget that point to point. Point to point. So we'll put it in the VRF. VRF forwarding for blue. And then we'll say frame relay interface DLCI 120, IP address 169.254.89.8. We'll make it a /24. So each of these sub interfaces has been dropped into the correct or associated with the correct VRF. Let's test. Do ping VRF blue over to the 169.254.89.8. Do I have connect? And look at that. We've got connectivity. Wash, rinse, repeat. Interface serial 0.130. Point to point. It's been a while since I've done frame relay. Point to point. And then we're going to say VRF forwarding green. And then we are going to frame relay interface DLCI. Frame relay interface DLCI, and it's going to be 130. And then we'll throw our IP address on here, 169.254.89.9, 255 dot. Oh, you know what? The IP address is actually, I put the wrong IP up on interface serial 000.120. I'm going to have to fix that, so give me a second here. So we'll sort this out. I got the right last octet here. So do ping VRF green. Let's make sure VRF green works. 169.254.89.8. So again, I'm pinging 89.8. That works. Let's get into interface serial 000.120. And let's say IP address, and actually this is where I should have hit the up arrow here to drop that in. And now let's rerun that do ping VRF blue 169.254.89.8, and let's rerun the command, and there we go. So we take a look at each of the serial interfaces. Do show run interface serial 000.10, and it looks good, and then 20. Oops, sorry. Do show run int serial 000. Oh, and it's let's say show run int serial 000.20. Did I screw that up? Do show IP interface brief. Oh, sorry. Show IP interface brief. Did I screw up that? Oh, lo and behold, look what I did here. And this is okay. In fact, you know what? I'm going to leave it like this. Right? Even though I diverged from 20 and 30, I'll leave it like this because, again, these don't have to match. Right? These don't have to match. The important value is the value that is under this interface, and that is that frame relay interface DLCI command, right? That encap.1q tag command. And I'm saying that as an analogy between serial and Ethernet. Okay, so again, we've got connectivity. My IP addresses are all correct. I've got my sub interfaces all screwed up, but hey, we're going to roll with it. And now let's go ahead and configure some sub interfaces and some OSPF. So let's get back into global config, and we're going to say interface loopback 1. Let me take a look at our drawing here just to make sure that I'm doing the same thing. So yep, interface loopback 1, VRF forwarding for red, and the IP address is going to be 9999, and we're going to make it a host route of /32. Interface loopback 2, VRF forwarding blue. Hit the up arrow a few times. Interface loopback 3, VRF forwarding for green. And we're going to hit the up arrow a few times because the IP is going to be the same. Do show IP interface brief. And there's our 3 loopbacks. We've got our 3 sub interfaces all configured, and we are now ready to do our router OSPF1 VRF red. And here we'll go ahead and set our router ID to the trip zeros and then 9, and then we'll do 99, and then we'll do 9.99. And so there's our router ID, and we'll say passive interface default. We'll say no passive interface for what? For serial 000.10. 10. And here's where I'm going to need to be careful because it's not 10, 20, 30. It's 10, 120, 130. And then we'll put our network statement in here for the 9999 and the quad zeros in area 0. And then we're going to bring up the adjacency immediately between router 8 and router 9. Network 169.254.89.9. That's my interface number, right? We do a quad 0 wildcard mask in area 0. And here's where you're going to see in a few seconds an adjacency come up, and there it is. What about a do show IP route VRF red? What routing information do I have right now? Well, you can see that I'm only picking up the information right now in the red VRF. There we go, for the local interfaces. But now that all of those link state update packets have gone back and forth and the link state acknowledgements have happened, here I now have a synchronized database with all of the other routers. And look who I see. I've learned intra-area OSPF routes about the 1111. I've learned intra-area OSPF routes, a route about the 2222. And then here is the VRF red network, right? That simulated loopback interface over behind router 1. So we can test connectivity right now. What about a do ping VRF red to the 10.1.1.1? Boom, we've got connectivity with VRF-Lite using serial subinterfaces with frame relay encapsulation over Ethernet interfaces with 802.1q encapsulated subinterfaces, then over individual physical links that are all in the same VRFs end-to-end, maintaining that end-to-end segmentation and separation of these networks. So now all we've got to finish up is router OSPF 2 VRF blue, and we're going to go ahead and say router ID 00099. We'll say passive interface default. I need to be careful here. No passive interface serial 000.120. And that is not 120, 120. And there we go. So now our network statements. Let's bring up the loopback interface here. We'll get that set up right away. Area 0. And then we'll say network 169.254.89.9 with a quad zeros and area 0. And here we're going to see another adjacency pop up, right? Across that sub-interface, proving that these sub-interface numbers are not important from a technical perspective. Again, from a realistic perspective, you want those to match when you can match them. And then finally, router OSPF 3 VRF green. And we'll say router ID 00.9.99. And then we'll say passive interface default, no passive interface, no passive interface. Serial 000.130. And there we go. Let's add our network statements in for the loopback address. And then let's add our network statement in for that 169.254.89.9 with our quad zeros in area 0. We're going to have an adjacency come up. We're definitely going to save this config. We've done quite a bit of work here. And you can see show IP OSPF neighbors. I've got 3 adjacencies, right? Same neighbor, but 3 different adjacencies over 3 different serial. And that's not what I wanted. Sorry about that. I'm trying to highlight the column here. I always forget if it's the option key. No, it's the option key. There we go. Over these 3 different individual serial sub-interfaces that are simply using frame relay encapsulation and a data link connection identifier. Think of it as like the 802.1q tag, except for frame relay encapsulation instead of Ethernet. And that's all we did right here over the serial interfaces. Because again, I can't do 802.1 tagging over the serial interface because it's not Ethernet. Show adjacency table detail. And now we're going to see it's point-to-point, right? All of these sub-interfaces are point-to-point. Where's my MAC address? There is no MAC address because point-to-point links, or as I say, serial connections do not have MAC addresses. because they're point to point. There are only two things involved, one thing on each end of this connection. There's no need for the MAC addresses like there are in Ethernet where it's multi-access. All right, so that just tested our connectivity. We'll say ping VRF, we'll do red 1111. It works. Ping VRF blue for the 2222. And then ping VRF green for the 3333. And actually, I did not use, let me go back. Did I use, oh, I'm sorry. That would have been router 3. I was going to do, should have done, there is no router 3. I pinged the 1111 in the VRF, and then I'm switching to 2222. Now it should be 8888. Again, just checking along the way here. So we'll say ping VRF green 8.8.8.8. And you can see that we have connectivity from end to end. All right, so that is going to be part 3, where we just configured back-to-back frame relay over this single physical serial link. We went ahead and using frame relay encapsulation and the DLCI value, carved it up into multiple logical sub-interfaces, point-to-point sub-interfaces, and then used our VRF-Lite to create another use case where you could do sub-interfaces and sort of maximize the connectivity. Maybe your company can't afford more than this single T3 or T1 link right here. And maybe this is going from Washington, D.C. up to Alaska. And you need to have multiple clients coming, or multiple missions, multiple clients, multiple whatever, tenants, whatever the case may be. You need to do some kind of virtualization across that link to make it happen. All right. Well, thank you guys so much for watching. Again, hopefully this is really driving home the power and the versatility and the different use cases where VRF-Lite comes into play. Thank you so much for watching, and I hope to see you in the next video where we're going to be taking a look at how we would do this with GRE tunnels. All right. Thanks for watching, and I hope to see you in the next video.